Hello students, in this tutorial we will see how to generate the parsing table and parse the given string I plus I. So first of all, consider the given grammar. Given grammar is E tends to T plus E, then E tends to T and T tends to I. So this is the given grammar. Now the step 1 is get the augmented grammar. So augmented grammar is nothing but G dash tends to G. So introduce a new symbol, that is E dash tends to E. Now in the step 2, what you have to do? In the step 2 you have to obtain the canonical set of items. So how to obtain canonical set of items? Consider the grammar, that is E tends to E dash. So I will write E tends to dot E. So because of this dot, all E's production will get that dot. T plus E. E tends to dot T. Because of this dot before T, T production also get dot in front of it. So in this way we build a state called as I naught. This is the first set of items we got. Now apply the transition. So what possible transitions are there? Whatever comes after the dot, that will lead to a transition. So E transition is possible, then T transition is also possible, and lastly this I transition is also possible. So I transition. So with E, what we get, just see, with E we get E tends to E dot. So E tends to E dot. This is what we get. There is nothing much we are getting with E transition. With T, what we get? With T we can have T dot plus E. So E tends to T dot plus E. Then this transition is also possible. E tends to T dot. Next transition we can have over the I. So with I we can have T tends to I dot. We'll just the name. This will be I1, this will be I2, and this will be I3. So in the first step we get 3 new states from I0. Now let us find the other transitions. So on this particular state, no transition is possible since dot is coming at the end. On this, the transition possible with plus. So we'll simply apply the plus transition over this. See what changes we can have. We will get a state like E tends to T plus dot E. Now because of this dot E, we have to write all E's transitions again, E's productions again. So it will be E dot T plus E, then E tends to dot T, and T tends to dot I. So everything we have to write again. So this is the new state T plus dot E. I'll just name this as the I4. Now next transition that can be possible on I4 is on E. This is so on E we will have T plus E dot. So E tends to T plus E dot. No other transitions are possible. This is the new state we got. We'll name as I5. Then if you apply other transitions, that is dot T and dot I, so we will get E tends to T dot, which is similar to the I2. Here also E tends to T dot plus E. So E tends to T dot plus E. This is already available. So on T it will give to I2, and if we apply I, that is it will lead to the I3 again. So just write this. If it goes on I, it will be I3. So this is the state diagram we got. We started from the I naught, we applied E transition, we get E1, we applied T transition, we get I2, we applied I transition, we get I3, then on I2 we applied plus, we get I4, on I4 we applied T, we get I2, on I4 we applied I, we get I3, and on I4 we apply E, we get I5. In this way all states are collected. This is called as closure. Once we get the set of items, we collected them, so called as closure. Okay, and when we apply E on I0, it is called as go to operation. So closure and go to, this is the operation we applied. Now in the step 3, what we will do, we will simply find out follow of the variables. Why I am introducing this step? Because from this diagram we will obtain the shift operation, which will be required in the next step to to form the action and go to table. So what we will do in the step 3, we will find out the follow of variable. Follow of variables. So which variables? Only E and T variable are available. So follow of E we will find out. Follow of E and follow of T we will find out. So what is the follow of E and T? See, any string derived from the variable, then what will be coming next, that is nothing but the follow of E. So to find out the follow of E, just look at the grammar. So E is followed by nothing. Here E is coming on the right hand side, and after E there is nothing. So follow of E is nothing but the dollar sign. Follow of E is nothing but the dollar sign. So in this way we can write. Next, let us see follow of T. So follow of T, T is coming on the right hand side. After here in this production, after T there is nothing. So follow of T is nothing but follow of its left hand side. So what is follow of E? Follow of E is nothing but dollar. Again, follow of E is nothing but follow of T is nothing but first of T. Follow of T is nothing but first of T, since T is the last symbol, so it can be I. And lastly here the E transition, you can observe here E production, the follow of T is nothing but plus, so plus could be the follow of T. So in this way we have obtained the symbols for follow of a variable. So follow of E and follow of T is like this. Okay, now in the next step what we will do, we will find out the states which will be used for the reduce operation. So just look at the this particular state diagram. From this state diagram and the given production, we will identify which states can be utilized or used for the reduce operation. So first of all, I'll just name the given productions. So first it will be E tends to T plus E. Then second one E tends to T, and third one, that is T tends to I. So these are the states I have written, and just name as step 4. So in the step 4 the numbering is given to the production. Now identify the states which are having dot at the end, called as final states. So just look at here the states that I will use as a last state. It will be I2, I3 and I5. So reason why So I'll write the I2, A3 and I5. Why I am writing this? Just see. In the I2 you can observe the production is like this. E tends to T dot, which is similar to the R2. E tends to T, whereas I2 is consisting E tends to T dot, which are similar to each other. So whenever you have I2, you will be reducing it with the production number 2, that is E tends to 2. So I'll write the R2 over here. Then for the I3 consists of T tends to I. So T tends to I dot. So T tends to I dot similar to 3. So when R3 is coming, I3 is coming, I am reducing it with the R3. And I5 state, just look at the I5, E tends to T plus E dot. It is similar to the production 1. So reducing with 1. So in this way we identify candidate states for the reduce operation. These are I2, I3, I5. So just make a mapping with the given productions and reduce those states with the R2. Now where we will write R2, R3 and R1 in the action and go to table, we have to write this R2. We have to write this R2 for the symbols that are in the follow of left hand side. Write R2 in the symbols that comes on the follow of left hand side, that is follow of E. So what is follow of E? That is dollar. So when you have transition possible on 2 with respect to dollar, write R2 there. When R3 will write the R3 for the symbols coming in the follow of T. So what is follow of T? That is dollar. So when you have 3 comma dollar or 3 comma I or 3 comma plus, at that time you will write the R3. And when R1 will be written, when you have transition over the left hand side, that is E. When you have transition from I5 to left hand side's follow. So what is left hand side? E. What is follow? Dollar. So when you have transition like 5 on dollar, we will write the R1. So in this way we have created the suitable states for the follow operation or reduce operation. Now in the next state we will create the parsing table. So just name it as a step 5, where we will create the parsing table. For parsing table, what we require? We require the input, all the coming from this generated diagram. So this diagram will help us to get the entries of action and go to. So for the action part, we will get the shift operation and reduce operation, and for go to, no shift or reduce notations or operations are written. In the action part, shift as well as state which is to be shift is written. In the go to, only state number is written. So just see I0 on I plus and dollar possible or not, and I0 on E and T possible or not. So I0 on E, you can observe I0 on E going to I1. So we will write I0 on E going to 1, I0 on T, I0 on T going to I2. So I0 on T going to I2. Then any possible transition, I0 on I is going to 3. So I0 on I is going to 3, but it is action part, that is why shift 3. Then I1, look at the I1, it is going nothing. So it is the, what we can say, accept state, and accept state is always goes on dollar. So at dollar we will write the accept. Then I2 on plus goes to I4, I2 on plus goes to I4. So I2 on plus goes to I4, that is shift 4. Next I2 is having only one operation. Then I3 also doesn't have any operation, all are incoming edges. Then I4 on T goes to I2. So I4 on T goes to I2, that is why 2. And I4 on E goes to I5. So I4 on E goes to I5. So only state number as a go to part. Then I4 on I goes to I3. So I4 on I goes to I3, that is why it is shift 3 operation. So I guess all shift operations are completed. Also go to part is completed. Now we will write the reduce operation. So 2 on dollar will be R2. So 2 on dollar will be R2. Similarly 5 on dollar will be R1. So 5 on dollar will be R1. And lastly 3 on dollar, 3 on I and 3 on plus will be R3. So 3 on I, 3 on plus and 3 on dollar will be R3. So in this way this action and go to table is also created. Now next step we will see how we can parse a given string. Okay, in the last step, that is step number 6, we will see whether this parsing table parse the given input string or not. So for that reason, create a stack which will contain the very first element, that is top of stack is nothing but state number 0. Then write the input string into the input buffer, and it will be ending with the dollar, and we will write the action, that is shift or reduce. Okay, so I'll just name the I have already named it. So these three grammars are equal during the reduce operation. So let us start. So in the first state, what we are going to do, we are looking from top of stack to the current input symbol. So current input symbol is I. So 0 on I, look into the parsing table. So 0 on I, it is nothing but the shift operation. So I'll write here shift operation. So shift operation means what? Shift the state. So I'll shift into the stack, that is 0, then state number, that is symbol I, and state number 3. This is shifted on the stack, and now input will be plus I and dollar. So now input will be at, input pointer will be on plus. Now look from 3 to plus. So look from 3 to plus, it is nothing but the reduce 3 operation. So reduce 3 operation is nothing but use the third production. What is the third production? That is t plus I. So instead I'll write here the first production is E tends to t plus E, E tends to T, and third production is T tends to I. So reduce with the reduce, what we have to reduce 3 on plus. 3 on plus is R3. So reduce with the third production. So reduce with T tends to I. So how we can reduce this? Simply look on the right hand side how many symbols are present. So one symbol is present, so we have to remove 2 stack entries. So we will remove these 2 stack entries, I and 3, and we will insert this T onto the stack, and we will find the new state. So it will be 0, then T, and new will be 0 on T. Look at 0 on T, it is nothing but the 2. So it will be the new state called as 2. So next, look from top of stack 2 to the input symbol plus. So 2 on plus. So 2 on plus is shift operation. So it is nothing but the shift operation. It remains same. shift operation. What we have to shift? 2 on plus shift 4. So 0 T 2 shift 4, that is plus sign will be shifted and 4 will be the state. So plus is moved. Now I and dollar will remain. Now input pointer will be on I. So 4 on I is S3. So again shift operation. So 0 T 2 plus 4 shift. What we have to shift? We have to shift T. We have to shift 4 on I, that is 3. So shift I is shifted and we will be having dollar. So I is shifted and state number is 3. So now 3 on dollar, we will see 3 on dollar. What is 3 on dollar? 3 on dollar is R3. So reduce with third production, T tends to I. Since we have one symbol on the right hand side, we have to remove 2 stack entries. So 2 stack entries will be removed. So it will be 0 T 2 plus 2 stack entries are removed and T will be inserted. So 4 and T. 4 on T we have to find out. So 4 on T, it is nothing but the 2. 4 on T is nothing but the 2. So next, look from 2 to dollar. What is 2 to dollar? 2 to dollar is R2. So 2 to dollar is R2. So reduce with the second production. So what is second production? E tends to T. E tends to T. So reduce again. Since one symbol is present, remove 2 stack entries. So 2 stack entries will be removed and E will be inserted. Here 2 plus 4. E will be inserted and new state will be 4 on E. So 4 on E is nothing but the 5 and the still current input symbol is dollar. So 5 on dollar we have to find. What is 5 on dollar? 5 on dollar is R1. So reduce with the first production. So reduce with E tends to T plus E. So we have 2 symbols are there. We have to remove the 4 stack entries. So it will be 0 T 2 and E will be inserted and new state will be 2 on E. So 2 on E is nothing but there is no such state available on 2 on E. What we have? 2 on E. 2 on E is not possible. So let us see. Now we will see 2 on dollar. So 2 on dollar is nothing but the 5 on dollar. Sorry, here 5 on dollar is nothing but the 5 on dollar is nothing but the R1. So we started reducing with the R1, that is first production T plus E. So 4 entries have been reduced and 2 on E is 2 is there and E is there. So here basically when we see from 5 on dollar, 5 on dollar is nothing but the R1. So we wrote reduce with the first production, that is E tends to T plus E. So total input symbols are 3, that is 1 2 3. So 3 symbols equivalent to 6 stack entries. So remove 6 stack entries. So 1 2 3 4 5 and 6. 6 stack entries are removed. Hence we have only remained with the 0. So now 0 on dollar we have to look. 0, sorry, E has to be inserted. So we have to see 0 on E. So 0 on E is what? 0 on E is 1. So new state will be 1. And next step we have to see from top of stack, that is 1 on dollar. So 1 on dollar is what? 1 on dollar is accept. So in this way string got accepted. I'll show you how the string got reduced. So how it got reduced, just see. The input string is I plus sign. Now just focus on all shift and reduce operation. So first we shifted I, so I is coming, then we reduce t tends to I, that means this I got reduced to t, then we shifted plus sign, then we shifted next symbol is I, then we reduce again the newly inserted I with t, so here we get the t. Next we have reduced e tends to t, so whichever is the recent insertion, that is t, it got reduced to e. Since it is bottom up parser, so it is called as rightmost derivation. So rightmost part is basically derived first, so rightmost derivation, so rightmost t is like replaced by e, and later on when we have the next reduce operation, that is e tends to t plus e, so this t plus and e, t plus e is reduced to e. So in this way we started with the input string and we derived the starting symbol. So this is nothing but the type of bottom up parser, BUP. Okay, so in this way you solve the example based on SLR parser.